Great. So welcome to Intro to Virtual Kubelet featuring KIP by Elotl talk. First, maybe I will uh, introduce everyone with this shortcut. So KIP is short for Cloud Instance Provider. And as Virtual Kubelet is a library, there are many providers built using that library, and KIP is the one built by Elotl. So let's start with agenda. So first, I'm going to talk briefly about myself. Then I will try to answer the question, uh, why is virtual kubelet needed and what problems it tries to solve. Then we'll dig a bit deeper into what's actually virtual kubelet. I will also do a short demo using KIP. And after that demo, I'll talk about caveats, and hopefully we'll try to leave you with some takeaways as well as references. And I'm also going to acknowledge some folks that either helped to create this presentation or I borrowed some slides from. So hi again, I'm Paweł Bojanowski. I'm platform engineer at Elotl. Before I was at Sauce Labs for about 2 years, and at Sauce Labs I was using Kubernetes mostly from end user perspective, and now I have a chance to work more on Kubernetes internals and controllers. I started my career as a web backend developer, and then I switched into more cloud native space. So to answer the question why we need virtual kubelet, we probably need to start with the classic Kubernetes architecture. So usually in the Kubernetes cluster, there is a control plane running on the master node with few services such as etcd, which is key value store, API server, scheduler, and control manager. And anytime you create a pod using API server endpoint, then the scheduler will try to schedule it on one of your worker nodes, which are just machines that are running less components, but they are able to basically run your pods. So that's very high level overview. In public cloud managed cluster offerings, usually there are some abstractions to manage your worker nodes. So let's say for such specific workloads, you need worker nodes with GPU. Then probably you will have different types of worker nodes, probably grouped into node groups. Depending on the cloud provider, the node group can contain very same instance types. It's a constraint on GCE. On AWS, you can have different instance type in one worker group, but they have to have same amount of resources. So at this point, if you have your cluster running, at some point probably you need more worker nodes as your traffic grows, and you've got few options. So you can either provision new worker group, or you can exercise the cluster autoscaler, which is service that basically runs inside your Kubernetes cluster and operates on the autoscaling group abstractions. So once you have that, you need to create autoscaling groups. Probably you have to pre-plan for limits for maximum and minimum number of of instances in each autoscaling group, and you also need to manage the cluster autoscaler. So all that adds complexity to already complicated Kubernetes operation, because, as I said, you need to maintain the autoscaling groups as well as the cluster autoscaler. So here comes Virtual Kubelet into play. So contrary to the regular nodes, Virtual Kubelet proposes this concept of virtual worker nodes, which isn't actually the hardware, the compute, but rather a service which first knows how to handle the compute lifecycle. So as you may see, this node condition, operating system, and capacity. This is about handling mostly the compute lifecycle, and there are also methods for handling pod lifecycle, as well as reporting the status. So, but in essence, virtual kubelet provider is basically a pod. And as I said, it talks with API server and says, hey, I'm a worker node. I know how to run your workloads. If you have workloads that I can run, I can handle it. So you may be wondering what you can gain using Nodeless Kubernetes cluster. By Nodeless, I mean a cluster that has a virtual kubelet provider in it. So one big benefit is that virtual kubelet cluster can provision just-in-time right-size compute for your pod or for your workload, and it will terminate this compute once your pod is terminated or your workload is done. And it also has seamless interop with control plane. So from operator point of view, there's basically almost no difference in scheduling deployments and managing it. On virtual worker node, it looks the same as on the regular node. So actually, Virtual Kubelet advertises a very large amount of capacity, but in fact, it uses as much capacity as is needed. And depending on Virtual Kubelet provider, because as I said, Virtual Kubelet is a library, under the hood, the compute could be, let's say, on-demand EC2 instances in AWS, or preemptible VMs in Google Cloud, or even maybe Cloud Run. That's all depend on that logic is encapsulated in Virtual Kubelet provider. So if you compare this to vanilla Kubernetes cluster, in such clusters, usually you've got worker nodes, which are usually pretty powerful machines. So the scheduler tries to feed your pod on one of those worker nodes. But there's always some waste generated because there's almost never a situation when the worker node resources are used in 100%. Which is different in Nodeless Kubernetes, because if scheduling your workloads is done on the virtual node, the virtual kubelet provider will try to pick the right-sized instance for each pod, and one compute machine actually runs one pod in that scenario. So let's do a quick demo using KIP. So what I'm going to do here, I have a AKS cluster already created, and we are going to deploy KIP to this cluster, and then we will try to run, we'll try to schedule deployment into that cluster. and we will just observe the pod and the compute. So as you can see here, I've got just one node currently. And I will deploy KIP, and we will see if the node list is changed anyway. Let's see if the KIP is running. So it should be running in short time. Currently, KIP tries to validate the access to both API server and AWS APIs. Okay, I see it is running. So if we take a look at the nodes list, you can see we've got a new node. It is KIP provider, and it is really. Let's take a closer look on that node. Yeah, so as I said, it advertises a large amount of capacity. So as you may see here, it advertises 100 virtual CPUs and a lot of memory. And it also has a label type Virtual Kubelet that we are going to use now. So I guess I got this manifest for Nginx deployment here. It's pretty basic. Just pay attention to my resource request, and I'm going to use node selector just to ensure that KIP will be responsible for handling, for scheduling this this deployment. So the pod is in pending state right now. Let me just quickly move into EC2 instance. So as you may see, the EC2 instance is initializing. The T3A small instance type was chosen for my resource request, and it should be running. It should be in running state in about 30 seconds. Usually that's how long it takes to get to the running state. Yeah, pod is initializing. It should be running soon. One cool feature that I really like in KIP is that once the pod was scheduled correctly, we add pod labels and also some metadata to as EC2 instance tags, which is really convenient for billing purposes, because then on the billing breakout you can clearly see how much you pay for compute for a given service. Okay, so the pod is running, and to simulate the scenario when the traffic is rising, I will just scale this deployment to 2 replicas, and we will see what's happening now. So another pod got scheduled, and I expect that the same instance should appear here. Yeah, so another instance is initializing. Is basically a same as the previous one. And let's just wait a bit till it's in running state. So yeah, that's what would happen if you have horizontal pod autoscaler and the traffic in your application is growing. Then the autoscaler should kick in, create a new pod, and then the KIP should create a new EC2 instance for running the pod. Just to show you the full life cycle, I'm going to delete this deployment right now. And we should see that immediately once the deployment is deleted, those instances are shutting down. So the KIP basically sent a signal to shut down these instances as we don't need them anymore. So let's get back to presentation. So what we have just seen is completely standard Podspace progression, and from operator point of view, there is nothing extraordinary in that. But I guess we are all more interested what is happening under the hood. So we created a pod, and that's the request Cube API server received. And it's then scheduler tried to get the node for running the pod, and our virtual worker node was matched by node selector. And from that point, the scheduling was handed over basically to the KIP, and KIP just considered the resource request, and it picked the optimal instance for a given request. Then the EC2 instance was booted. Elotl node agent was deployed there, and from that point, the communication between control plane and the pod is handled both by KIP and this node agent. And KIP also handles the full life cycle of the pod as well as the life cycle of compute. So what you gain from running Nodeless cluster is definitely simplified operations, because as you saw, there is basically no difference from operator point of view. You don't have to maintain and upgrade your worker nodes if you are using any virtual kubelet provider. You don't have to use cluster autoscaler, and you don't have to pre-plan for limits for autoscaling groups, also managing those limits. Another benefit is really strong isolation, as each pod runs inside the VM. And you can get significant cost savings, because you basically run the compute only as long as it is needed. So what are use cases where KIP really shines? Well, CI/CD automated tests, and basically all kinds of workloads that are bursty. So if you have, let's say you have development team in one time zone, then probably your CI/CD is pretty idle outside the working hours. But if you are running regular Kubernetes cluster, you still pay for the compute. With KIP, you can save this money. If you have distributed development team, then probably KIP can just scale in your compute on the weekends, because I hope nobody works during the weekends. Another use case is where you need specific or expensive hardware. So for machine learning, usually you need worker nodes with GPU capacity, and those are usually pricey. So with KIP, you can just pay only for the time when your machine learning workloads are running. Another use case, if you have on-prem Kubernetes cluster in your private data center, and you don't want to stack another machines in your data center to have more compute, you can deploy KIP there and burst into public cloud to AWS or GCP using KIP. So that's another use case. Obviously, there are some caveats. So we currently support only stateless workloads, so persistent volumes are not supported. Also, in nodeless clusters, the idea of daemon sets doesn't make a lot of sense. But as a workaround, you can use sidecars containers into pods. Another possible caveat for some people could be just list of supported cloud providers. So as I mentioned earlier, we support AWS and GCP currently. As I said on the beginning, Virtual Kubelet is a library, and there are multiple providers built using that library. So another examples, it's Azure AKS allows you to burst your workloads on Azure container instances, which is their containers as a service offering. And this under the hood also uses Virtual Kubelet, as well as Netflix. If you watched Netflix this week, under the hood, it was running using Virtual Kubelet. So there is a slide with references. Both KIP and Virtual Kubelet is open sourced, so I encourage you to take a look at the code. We also have Terraform examples for trying nodeless cluster on GCP and AWS, and we have Medium blog covering some of use cases. And I would also want to thank everyone from the Elotl team for basically developing KIP and also helping with creating this presentation, as well as a few Virtual Kubelet community members. And I will also thank you for your attention. And if there are any questions, I'm happy to answer those either on chat or offline. There is my email. If you have question more like regarding Virtual Kubelet, there is Virtual Kubelet channel on Kubernetes Slack. And if you bump into any issues using KIP, I encourage you to create an issue in our repo. And that's pretty much it. Thank you.